Hello friends, today we are learning what is LED. LED is a light emitting diode, is a semiconductor device that emits light when an electric current flows through it. Friends, when current passes through an LED, the electrons recombines with holes and emitting light in the process. LED allows the current to flow in forward direction and blocks the current in reverse direction. Light emitting diode are heavily doped PN junction based on semiconductor material used on amount of doping. An LED will emit a colored light at a particular special wavelength when forward bias. As shown in figure, an LED encapsulated with a transparent cover so that emitted light can come out. Look here, the symbol of LED, friends. The figure shows a simple LED symbol, the addition of two small arrows denoting the emission of light. The arrow represents the emission of light, friends. Look here, friend. What does a light emitting diode do? Compared with the conventional light sources that first convert electric energy into heat and then into light, LED, that is light emitting diode, convert electric energy directly into light and delivering efficient light generation with little wasted of electricity. How do LED works, friend? LED work on the principle of electroluminance. On the passing a current through a diode, minority charge carrier and majority charge carrier recombines at a junction. On recombination, energy is released in the form of photons. As forward voltage increases, friend, the intensity of light increases and reaches a maximum. Look here, friend, I explain in brief. When the diode is forward biased, the minority electron are sent from P to N, while minority hole are sent from N to P. At the junction boundary, friends, the concentration of minority carrier increases and the excess of minority carriers at the junction recombine with the majority charge carrier. So what happened when the energy is released in the form of photon of recombination? In standard diode, the energy is released in the form of heat. But in light emitting diode, the energy is released in the form of photons. And we call this phenomena electroluminance. Electroluminance is the optical phenomena and electrical phenomena where a material emits light in the response to an electric current passed through it. As the forward voltage increases, the intensity of light increases and reaches a maximum. Hope so now you friend understands. Look here some properties of LED, friends. Laser light is monochromatic, means unlike white light which is made of 7 colors, laser light is made of single color. The light emitted from laser is monochromatic, that is, it is one of wavelength, means color. In contrast, ordinary white light is a combination of many different wavelength, means colors. So next is laser light is directional. Laser light is a highly directional. Laser light is emitted as relatively narrow beam in a specific direction. Ordinary light such as a coming from sun, light bulb or candle is emitted in many directions away from the source. Look here, friends. Laser light is coherent. That means laser light is coherent because the wavelength of laser light are in phase with space and time. Mostly light emitting diode used in TVs and color display. Look here, friend. Light emitting diode, commonly called LED, are real heroes in electronic world because of they do many different jobs in all kinds of device. They form number of digital clocks, transmit information from remote controls, light up watches, and tell you when your appliances are turned on or off. Friends, look here the VI characteristics of LED. Basically, a LED is a semiconductor device which emits light when current is passed through it. LED are always connected as forward bias. The VI characteristics of LED is the same as the diode connected in forward bias condition. So for more details, watch my previous video Forward bias means what? Look here friends. What determines the color of an LED? The color of an LED is determined by the material used in semiconducting element. The two primary materials used in LED. First one is friends aluminum, gallium, indium phosphide alloy. Second one is indium, gallium nitride alloy. The aluminum alloy are used to obtain red, orange, yellow light friends. And indium alloy are used to get green, blue, white light friends. Slight changes in the composition of this alloy friends, the change in color of emitted light. Hope so you understand today's topic light emitting diode friends. Thank you.